The production of ferrofluid is an excellent example of the bottom-up manufacturing process. A ferrofluid is a colloid, consisting of nanoparticles of a magnetic compound suspended in liquid. Ferrofluids can be made from a variety of metallic element mixtures, the most common of which are iron salts, which produce a compound called magnetite. In this experiment, we will make a ferrofluid, that is, a magnetic colloid, by creating nanoparticles of magnetite and suspending them in solution. We will then investigate its magnetic properties in response to an external magnetic field. We will measure out small volumes of the iron solutions, the ammonia solution, and the surfactant in the quantities shown. The solutions and equipment are 4 ml of ferric chloride solution, 1 ml of ferrous chloride solution. This should be greenish in colour. Any brown coloration indicates oxidation, which makes it unsuitable to use. 50 ml of aqueous ammonia solution, 1 ml of tetramethyl ammonium hydroxide, otherwise known as TMAH, a surfactant, a magnetic stirrer, and burette. Let's create our nanoparticles of magnetite. Here's how we do it. We pour 4 ml of the ferric chloride solution, which is the brown coloured solution, into the beaker containing the magnetic stirrer. Into the same beaker, we add 1 ml of the green ferrous chloride solution. This is a 50 ml burette, so we'll start adding ammonia solution from the 0 mark and allow it to drip slowly into the beaker until the solution in the burette touches the 50 ml line. It should take 5 to 7 minutes to add 50 ml of ammonia solution. You can see the colour changing in the beaker as more and more of the ammonia solution drips in. When it starts turning black, we are seeing the presence of black magnetite particles. Even though the mixture is totally black at this point, it is important that we add the full 50 ml of ammonia solution. It's the black particles we're interested in. Magnetite is a mixture of ferric ions, ferrous ions, and oxygen. These magnetite particles are the basis of our magnetic liquid. And this is the chemical equation for making magnetite. Okay, we have precipitated magnetite. How do we turn this into a ferrofluid? We do this by adding a surfactant that will coat all the magnetite nanoparticles, giving each particle the same electrostatic charge to ensure they repel one another. This is what keeps the particles suspended in the surfactant. Here's the process. First, remove the stirring bar from the beaker of magnetite using a standard bar magnet. If you slide the bar magnet slowly along the side of the beaker, you'll see the stirring bar follow it up, covered in black particles. Wash the majority of the particles back into the beaker with distilled water. Put the stirring bar aside and continue working on these black particles. If we leave this beaker stand for some time, the particles will settle to the bottom naturally, but we can accelerate the process using rare earth magnets with strong magnetic fields. If we set the beaker on top of the magnets, you should see the solution starting to clear. With the magnets still in position, tip off the excess liquid. Slide the magnets away from the beaker and wash the remaining particles with distilled water to remove any excess ammonia. We'll gently swirl the contents of the beaker and again place it on the magnets to allow the solution to clear. Then, with the magnets still in place, we tip off the excess water. Repeat this washing sequence one more time and tip off the excess water. Then wash the particles from the beaker into this small container, sliding the magnets underneath. Let the particles settle, then tip off the clear solution. Repeat these steps until all the particles have been transferred to the small container. Our final tip out should leave us with a layer of magnetite particles at the bottom. If there's still a little excess water, we remove it with a plastic pipette. Now add 1 ml of the surfactant, again using a pipette, and stir the mixture for about 1 minute. We have now charged the surface of each of the particles. They'll all have the same electrostatic charge, so they'll now repel one another. We set the container back on the magnets for a minute to again draw the majority of the black particles to the bottom. We can then draw off any excess surfactant. The aim is to have the surface of the black layer liquid-free. We have created magnetic liquid. We now have a colloidal suspension of magnetic nanoparticles. But how do we know it is a ferrofluid? We can observe its magnetic properties by experimenting with an external magnetic field. If it is a ferrofluid and it has the correct consistency, it will visibly react. If we remove the magnets, we should now see the ferrofluid flow like a liquid. If we place the magnets nearby and the consistency is correct, you'll see the ferrofluid spiking and changing shape at the surface. As you can see, we've got it right. Ferrofluid exhibits different responses to different strength magnetic forces. Hold the magnet really close and the liquid just follows the magnet around. Hold the magnet nearby and we change the consistency from liquid to semi-solid. It's these magnetic properties that have resulted in many industrial applications of ferrofluids. They are also of great interest to medical scientists. We have produced from iron salts and ammonia solution magnetite particles. Coating these particles with surfactant has given us a ferrofluid that responds to an external magnetic field.